We're going to be talking about translations and transformations. Just in general, a transformation is when you take an image and you are moving it somehow. And that movement could be a variety of different ways. It also could include making it bigger or smaller. You're just using that image, and like I said, you're moving it in some way. So, a vector has both magnitude and direction. Big surprise, you guys probably already knew that. Now, thinking about this. So, a vector realistically is direction and magnitude. Yes, I get that. But mathematically, this is just how you get from one point to another. Okay? So, looking at example 1 here, you need to look at a picture and kind of understand what I'm talking about here. So, name the vector and write it in component form. So, the vector, there are two different ways, not two different ways. There are two things you need to know about a vector. B, since B is considered our initial. K is where we're going. Okay. With that, this is just like when we talked about rays. You need a direction that you're going, and the arrow is telling you where you're going. So you have vector BK. In component form, what this is saying is we're trying to figure out how do you go from your B to your K? What do you have to do left, right, and up, down? So we have, it kind of looks like an inequality sign. It's really not, but just kind of mentally look at it that way. So how do I go from point B to point K? I have to move to the left 5, aka negative 5. Then I have to move up 2. This right here is my component form of that vector. How do I get to B to K? Okay. A translation. This is, you could think of it as a slide of an image. Okay, once again, I always think it's easier if you talk about an example to understand the definitions. So if I'm looking at this, translate the image xy, so that triangle, into x plus 3y. So what I'm doing is I'm moving those coordinates to the right 3. I don't have anything with that y, so I don't have to move it left or right, or up or down. So I'm going to take my points and I'm going to move them to the right 3, each one of them. When you are moving a point, this is going to be a prime. This is now E prime. This is showing the original, and then now the translate, in this situation, translated triangle. So W, move it 3 to the right. Make sure I label it W prime. G, do the same thing. Again, make sure you label. Now I connect. That's a translation. You just slide your image left, right, up, down, depending on what you've been given. So on example 3, we're going the reverse way. We're supposed to figure out the translation rule. So the translation rule, the big thing here, it's kind of like our vector. However, you've got x, y, formation-wise. Have to draw that arrow. Now, remember, you're going from 1 to prime. So if I'm looking at B prime here, this is also tricky. This graph goes by 2's. Because, we have to make it complicated for you. So if I'm looking at that B coordinate, Okay, and it might help to look at it individually as the coordinates. B is located at -1, 5, and it is now at 4, -1. So if I'm trying to find a rule, how do I go from -1 to 4? Well, I have to add 5. So this is now x plus 5. Then you have to ask yourself, okay, how do I go from 5 to -1? You have to subtract 6. So y minus 6. This is our translation rule. So once again, make sure you're checking out your graph and figuring out if you're going by 1s, by 2s, by 3s, whatever you're going by. And then if it helps, you can use coordinates and use that example to figure out what are you moving left, right, up, down by. Okay. Couple more things here. A rigid motion, this is a transformation in which the image holds angle measures and side lengths. So when we're saying holds, they keep it the same. They're all congruent. We'll talk about different rigid motions, but a translation is a rigid motion. Nothing changed as far as the angle measures or the side lengths. They all stayed the same on both of these situations. So a translation is a rigid motion. We will talk more about them and figure out, are all of the transformations rigid motions? The answer is no. So I'll highlight the one that's not for sure. Composition theorem, this is where you will have 2 or more transformations to complete. When you're doing this, it does not matter the order, so just something to think about. On example 4 here, we need to graph our points, then we have 2 translations, which means we're going to end up with 3 different triangles, so just make sure you're aware of that. So on the original, I've got -2, 8. Make sure I label it. 1, -3. That's K. Not a prime though. Sorry. And then I've got 5, 4. Big triangle. Sorry. My first translation is to move all of my points to the right 6 and down 1. So I'm going to start with my L prime. I don't know why, I just feel like starting there. On the edge of the graph, which is all right. So that's L prime. K prime is now located here. And J prime, 1, 2, 3, 4, 5, 6, down 1 is here. This is translation 1. Now, when you're doing your composition, you're not going to go back to the original. Now you're going to do the second composition with your image points. This is now going to be a double prime. So all of these coordinates have to go left 1 and down 7. So I'm going to start with J prime. Left 1, down 7. This is now J double prime. L prime, again, left 1, down 7. And K. Again, right on the edge of that graph. And now I connect. So a composition, really not that big of a deal. You just look at each one of your transformations individually and then move them as necessary. This is transformations. Translations, which is a transformation.